inside of Met Council Environmental Services, which is the organization that runs the wastewater treatment plants for the Twin Cities. We've got a good cross-section of water resources practitioners, chemists, biologists, engineers, a lot of technical staff representing 3 or 4 different divisions. And so I appreciate your attendance, and I think that these joint meetings of Met Council staff and TC WMODG staff have really worked out well. It was a good experiment to undertake during our quarantine, and I think it's something that'll last beyond. I think this format will last beyond quarantine. Go ahead, Jen, tell us about TC WMODG.
Yeah, so my name is Jen Kostrowski, and I have the pleasure of co-facilitating TC WMODG, which stands for the Twin Cities Water Monitoring and Data Assessment Group. We are a partnership of public sector water professionals, so that's everyone from federal, tribal, state, regional, watershed, municipal, and county. I think I got everyone there. Staff that deal with water resources or try to monitor and assess the water resources of the Twin Cities region. Our group is pulled together with the vision to hopefully establish and promote standard practices for water monitoring and analysis within the Twin Cities. And in the end, our goal is to create quality information so that we can effectively manage, protect, and improve the regions within the metro area. So I want to welcome all of the TC WMODG members who are on the call, and we look forward to hearing what Helen has to say.
Great, thanks. I think I forgot to introduce myself. I'm Cassie Champion. I coordinate the stream monitoring program for Metropolitan Council. And next, I'd like to introduce our speaker. Helen Goeden is a senior toxicologist from the Minnesota Department of Health, and she's going to talk about a program that they're working on, drinking water contaminants of emerging concern. And if you do have questions, especially clarifications during the course of her presentation, please either raise your hand or chat it into the chat. Jen and I will be monitoring the chat and the hands raised as best as we can and try to kind of break in when you're in presenter mode. It's very difficult to see other parts of Teams. Teams doesn't pop apart the way that Zoom does. Maybe it will someday, but so we'll be kind of monitoring those questions for Helen, and of course you're welcome to save questions for the end as well. With that, Helen, thanks so much for joining us today, and take it away.
Thank you. Try and get this in presentation mode. There we go. Hopefully that worked. Well, I'm really happy to be here and share with you the work of our program and be certainly engage in answers and questions. And I'm happy to be able to share all this information with you today. So what I'd like to sort of cover is background and history. I find it interesting how we got to where we're at, sort of thing, and I think it sets a nice stage for the rest of the talk. And then I'm going to talk about the process we use within the CEC program to rank chemicals that are nominated. That ranking is used to select chemicals for a full in-depth review with the intent of developing water guidance. I also want to touch on the Department of Health's risk assessment methods that we use for guidance development, because they are actually fairly unique in what we look at and what we focus on. And then, although guidance development is the bulk of what our group does, we are involved with a variety of other special activities that I think would be of interest for you to know about as well. So history, I have been a toxicologist working in environmental area, human health, for over 35 years, and really up until about the late 90s. The focus of that risk assessment, et cetera, was really on chemicals that were released from industrial sources. So, end of pipe, end of smokestack, RCRA sites, Superfund sites, that sort of thing. So we were really focused on those types of point source areas of contamination. But that really sort of changed in the early 2000s. And part of that change was caused by a sort of earth-shattering publication by USGS. For the first time someone went out and looked for a very wide range of contaminants that were not necessarily industrial source contaminants, and did a national reconnaissance in the US. And this was by USGS. And they looked for hundreds of pharmaceuticals, hormones. This says organic wastewater contaminants, but really what it is a lot of consumer product related contaminants, et cetera, that, wastewater tends to be the place where it gets collected, but wastewater is not the source itself of those contaminants. So this really was sort of a wake-up call. And it really wasn't terribly surprising because of the, unfortunately, incredible volumes of pharmaceuticals that are used in the United States, as well as just the amount of consumer products. So it's not really surprising that the chemicals associated with those types of products are very high volume often, and they get out into the environment because we use pharmaceuticals and consumer products. So this story actually still remains one of the environmental science technology's most cited publications. And shortly after this was published, the manager at the Department of Health Drinking Water Program actually contacted and collaborated with USGS to go out and do the same monitoring and sampling at water intakes for our surface water, public water supply systems. And that was a pretty risky thing to do because, they weren't sure what they were going to find. And if they found something, they weren't sure what they were going to say about it because most of these contaminants don't have guidance for them. So I think it's important to know that even though we now sort of have a formal CEC program, that, well before, 8 years or so before that, the effort and interest in emerging contaminants and ensuring the safety of our drinking water those efforts were already underway by people at the Drinking Water Program at the Department of Health. So why are we finding all these chemicals and why is that a concern? Well, we are a chemical-based society. There are over 100,000 registered chemicals, and it's been estimated somewhere around the area of 50,000 are in common use. So, and chemicals can make life much more convenient and easier, but the chemicals don't always stay in the products and where you want them to be. So we use a lot of chemicals in a wide variety of products and applications. So that's why they're out there, and why we're finding them is because we have some really, really good chemists. They are very good at looking for and finding chemicals. Over the course of the last 20 years, detection levels have dropped significantly, and the list of analytes has widened and expanded, so we can look for more and more chemicals now. And we're looking in more and more places. We're not just looking at point sources. We are doing, ambient monitoring across different media, and that even includes people. And that obviously sort of changes the perspective when, if someone were to tell you, well, you have fragrances in your laundry detergent, that may not be a big deal. But if they were to tell you those fragrance chemicals are found in your children, that's a whole different ballgame. So that information is more and more out there and readily available, and that raises questions and it raises concerns. And one of the reasons is because a lot of these chemicals do not have health-based guidance to provide some kind of context for what does it mean when we find a certain concentration of a chemical. So as many of you may know, EPA has enforceable standards, MCLs, for about 90 chemicals. And if you include EPA's Office of Water non-enforceable health advisories, we're still less than 200 chemicals. So there are, that's barely a drop in the bucket compared to the chemicals that can be monitored for. And this is just a reminder to me to say that these chemicals, once they get out into the environment, they can get just about anywhere. The Pollution Control Agency has been monitoring for emerging contaminants for some time, and they find them pretty much everywhere, even in far remote lakes and rivers. So the environment simply reflects our lifestyle, but they pretty much are everywhere. So I wanted to give a little bit of context, just what the role of the Department of Health, and in particular our program. So our program, in essence, has explicit authority to develop human health-based values for groundwater, and that authority comes under the 1989 Groundwater Protection Act. And the goal of that act was to, in essence, protect the groundwater in Minnesota as a potential resource. Now, those health risk limits are strictly health-based. The authority that is given to us does not mention consideration of technology or cost, which are obviously very important parameters, but we are directed to develop strictly health-based values. And those values represent a concentration of a chemical in water when used as drinking water that is likely to pose little or no threat to humans. Now, these are not enforceable standards. There's nothing in the rule that states that they have to be used or how they should be used. So it is really left up to various regulatory programs whether or not they want to use them and what manner they want to use them. The guidance we develop does have to go through rulemaking in order to become health risk limit standards for the state. And so we do try to do that every few years. Now, historically, we have had a health risk limit program actually since the late 90s. And, or actually, no, the late 80s. What am I saying? The late 80s. And that program still exists. That program was mainly focused on legacy contaminants, and our major customers were and still are sister agencies like the Superfund program and remediation program, et cetera. So the health risk limit program still exists, and it's in our same unit. So the CEC program is sort of a sister program to that group. And the reason we have an emerging contaminant initiative is largely because we had funding. It is funded by the Clean Water Land and Legacy Amendment that was voted and approved back in 2008. So the Clean Water Fund gets a portion of that tax revenue, and then a portion of that is dedicated to drinking water, and a slice of that actually goes to the Drinking Water CEC initiative that I work in, and it's located within the Health Risk Assessment Unit, along with the Health Risk Limits program. So a lot of what we do is develop health-based values for CECs in groundwater, but also surface water. This new initiative allows us to be more proactive and also look at surface water in addition. And it also does not require that the contaminant has to have already been found in Minnesota, but whether it has the potential to be there. Now, in addition to developing health-based values, we also use our funding to help develop analytical methods. We have some special projects, which I'll mention later in the presentation, and we have also funded numerous outreach and education grants as well. So first, I'd like to just share our definition of contaminant of emerging concern, and it's a quite broad definition. It's a substance that's been released to, found in, or has the potential to enter Minnesota waters. It can pose a real or perceived threat. It may not have guidance yet, or it could have guidance, but there's new information on its health effects or exposure that causes us to be concerned regarding whether or not that existing guidance is adequately protective. So it can meet this type of definition, and it would be considered eligible for our program. So this,
Helen,
oh, sure.
sorry.
Yeah. No, go ahead.
There's a question in the chat that says, do you focus on human source contaminants, or do you also look for natural chemistry, for example, manganese?
Yes, we also look for naturally occurring as well.
Thank you.
Okay. So this is a 5-step process starting with nominations. This is the process or steps that go from nomination through to guidance development and then communication of that development. So I'm just going to very briefly step through each of those. And the first one is nominations, and this is the URL for our homepage. I think if you simply Google MDH and CEC, this should come up. And nominations, oh, sorry, my little cues here. If you're interested in tracking our activities, the best and simplest way to do that is simply to subscribe to our, we have a free Gov delivery service, and you will get an email. We send an email out to our subscribers every time we initiate a review. We let them know which chemical we're starting to review. We let them know when we've finished that review. If we are considering going into rulemaking, that's something we announce. Recently, we announced our annual meeting that's coming up this summer. So we don't send out a lot of emails, so we wouldn't be filling up your email, but this would be a good way to sort of track our activities. So I highly recommend it. So to nominate chemicals, you can click where that red arrow is, and that actually takes you to an online nomination form. And we don't ask for a lot of information. We do ask for you to identify a specific contaminant and provide some information as to, why you're nominating it. What particular concern do you have? And if you're interested to know, well, what's already been nominated, you can click on where that second arrow is, and that will take you further down this page. And there is a nomination status table. It's a PDF document, and if you open that, it has a complete list of every contaminant that's ever been nominated to our program, whether it was eligible to be reviewed in our program, and if it was, where it is in the process. So whether it's already completed review or it's waiting to be screened, whatever that may be. But a complete list of what has been nominated, and sometimes things have been nominated more than once, that's also noted. But that's where that information can be accessed. There may be some interest in, what kind of chemicals have been nominated to our program. So to date, we've had about 150 chemicals that have been nominated. And the largest single category has been chemicals related to consumer products. And then the next is actually pharmaceuticals, followed by pesticides and industrial chemicals. Those four make up certainly well more than half of the chemicals, and that's been followed by disinfection byproducts, the PFAS compounds, and then the naturally occurring, such as manganese, and boron is another one. I think selenium is another one that's been nominated. Cyanobacteria, and then the smallest slice there is natural hormones. So given these types of contaminants, it may not be surprising that they are more frequently found in surface water bodies than in groundwater. We do have some things that are found in groundwater, but it is definitely more frequent that these contaminants are found in surface water. So I wanted to give a little bit of background too on how our screening process was developed. Once the program started, we had to figure out how would we get nominations and how would we, transparently and objectively screen and prioritize chemicals for guidance development. So we created a screening criteria and prioritization task group. And the function of that task group was to provide us input on developing an efficient and effective process. We solicited and got involvement from a very diverse set of stakeholders. So we had representatives from nonprofits, from consulting firms, from industry, federal agencies, state agencies, and several experts from academia as well. And we met over the course of, I think, about 18 months, and their key recommendations were incorporated into our process. And I just wanted to highlight what some of those key recommendations were. One of the very first ones was that the nomination process had to be open and transparent. So we do have that online nomination process. You can also send us an email or call. That also works. The other thing too is, we didn't want to have to completely reinvent the wheel. So we started out with using the US EPA Office of Water Contaminant Candidate Prioritization methodology. This is a methodology that's existed for several decades and has been repeatedly vetted, and is designed to prioritize from a larger group of chemicals those that basically warrant a closer look. And so we used that as our starting point for screening and scoring of the toxicity and exposure potential. But then what we did is we supplemented that with specific concerns that were identified by the stakeholders that they felt we should in particular look at and potentially add scores to reflect the information that we had. And those concerns were endocrine activity, but also including non-traditional contaminants like pharmaceuticals, which has not historically been included by Office of Water, and also to really focus on what is being found in Minnesota to the extent that we could do that. The other was that we needed to maintain documentation of the nominations and what status those nominations had. So we do that with the nomination table. That has the complete history of anything that's been nominated to our program. So each contaminant that's eligible goes through a screening, and we look at toxicity potential. So what that means is, how potent is that chemical? Do you need a little bit of exposure to see cause and effect, or do you need a large exposure? And then also, what type of health effect does it cause, and how severe is that health effect? And on the exposure side, we look at, release potential to the environment. Where does it go in the environment? Is it likely to end up in water? How persistent is it? And then we also look at any occurrence information in Minnesota or elsewhere in the country. And this is meant to be a screening level assessment, not an in-depth assessment. So what we do is we go out and we try to obtain publicly and readily available information on these questions, and then use that information and the scoring metric to create a score for toxicity potential and a score for exposure potential. And the exposure potential is focused on the potential exposure from water and drinking water. And then we use those scores to inform a ranking or a selection. So this is sort of a graphic presentation of, sort of high, medium, and lower concern. And obviously our interest is in that upper right quadrant, where you have higher toxicity and exposure potential. So we rank, this ranking, I want to make it very clear, this ranking is relative to other contaminants that have been nominated and screened. It is not a ranking of the universe of chemicals. So it is only those that have been nominated and screened within our program. We also look at the feasibility of developing guidance. What is the quantity and quality of particularly the toxicity information, and is it sufficient for us to actually develop a guidance? So this is sort of a judgment call at this point, in terms of what information we were able to identify and gather during the screening. There are contaminants of emerging concern that have such little or no toxicity data that we are not even able to score them, which means they're not ranked. Because there's no information by which to create a score. The other thing we consider is input from our stakeholders. We typically hold an annual meeting in the summer. At that meeting, we present the sort of screening results and ranking results, and we also usually present a preliminary or a tentative work plan. Which contaminants we think would make the best candidates for a full review. And we share that with our stakeholders, and we ask for their input both on the process that was used to come up with that result, as well as what's listed on the tentative work plan. In particular, we're interested in the need and usefulness of the review, and we certainly take that input into account because it has resulted in changes to the preliminary work plan. Anything that's not selected for this year's work plan doesn't disappear. It remains eligible for future selection. It remains in that pool. So that sort of completes the description of the process of up to the point of ranking and selection. So my next I want to do is just touch briefly on the methodology that we use to look at and evaluate the toxicity of contaminants, and then also to develop water guidance. Most entities are focused on chronic long-term exposure when they develop water guidance. And the basis of that is it's felt that if you're protective of long-term exposures, you'll be protected of short-term exposures. But within the last 15 years or so, there's been some question about that. And one reason is because of the potential for susceptible populations. There could be certain life stages that are quite susceptible to the toxicity that a chemical may have, but also for drinking water, there's a large difference between water intake rates over different life stages. In particular, infancy is an extremely high intake rate period. Infants are dependent solely on liquid nutrition, and their intake of fluid, including water, early in infancy is much higher on a per body weight basis than it is in older children and adults. So we look at highly exposed, which really is infants. They seem to be the most highly exposed. And we look at that short-term and subchronic durations as well, because that high exposure occurs, but for example, we're only infants for a relatively short period of our lifetime, but it's a sensitive period for toxicity sensitivity as well as high exposure. So we explicitly evaluate those things. And if the information is sufficient, we develop guidance for these different durations. So that is sort of new methodology. We promulgated that methodology back in 2008 or 2009 and have used it ever since. The cumulative assessment is actually been in our rules since the first rulemaking, which was in 1993. And what cumulative assessment requirement is if you have multiple chemicals present at the same time and they all affect the same health point, you need to look at the combined potential risk from all of those chemicals. So if you have 5 chemicals in the water sample and 4 of them all affect the liver, then you need to do a cumulative assessment. So once we develop our guidance, it is posted on this website, the Human Health-Based Water Guidance Table. And I just wanted to highlight a couple of things here, in particular the one that's circled, because this may be of interest to some people in the audience. We have a comparison table. There's a link that will take you to a table that actually compares all the state guidance that we've developed with federal drinking water standards, the MCLs, but also any existing health advisory. So there's a table that has all of that information in it. We also have, if you look a little bit lower, we have a MDH water guidance and additivity calculator that helps people conduct that cumulative assessment when there are multiple chemicals present. And there's a calculator within this Excel file for each of those different durations. And then for each contaminant, we have a couple pieces of documentation, and I'll just show those in this next slide. This is just an example for triclosan. So one is something we call a toxicological summary, and this is a more technical document, but it lays out specifically the basis for the numbers that we come up with. So it has the equation, it has the toxicity reference dose and what the basis of that value is, what we use for an intake rate, etc. So all of that is laid out in a summary form in this document. And the largest audience for that are typically people like myself, toxicologists and risk assessors, who are most interested in that document. We also put together a 2-page information sheet, which is more general, and people have used that for communication purposes. So it explains what the chemical is, whether it's been found in Minnesota, what our drinking water number is, what type of health effects are associated with the chemical, and usually also gives some background on, what are the most likely sources of exposure to that chemical. So that kind of wraps up the huge whirlwind of our in-depth guidance development. So I don't know if I want to pause here and see if there are any questions up to that point, and then I'll start on just, again, highlights of some of the special activities.
There's a question in the chat.
Okay.
Are there any particular chemicals that MDH is identifying and concerned about beyond nitrate and pesticides that seem to be making their way from the surface or surface waters into the groundwater used for drinking water?
Most of the ones that I'm aware of that seem to be popping up as concern for groundwater actually tend to be coming from sources like landfills, etc., or interchange between surface water and groundwater. Unless there's a specific spill or something on the surface, or what are those things called? RIBs, the rapid infiltration bases for wastewater, etc. There doesn't seem to be a particular, let's say, contaminant or class of contaminants that sort of filter down into the groundwater necessarily. Certainly PFAS is a group of chemicals that certainly remain certainly on our radar screen, and actually more than our radar screen. They certainly are taking up a lot of resources, and remain probably in terms of a single group of chemicals, one that we remain quite concerned about, and are spending a lot of resources on trying to track and analyze them.
Thank you. There's another question that says, or that asks, are microplastics on the list of contaminants of emerging concern?
Not quite yet, but we do have a special project, so I think they're mentioned in a few slides from now. So I'll get to that. Good question. So some of our special activities involve, this is the first one I'm presenting, partly because as I hinted or indicated before, we often may not have toxicity information for contaminants that have been nominated. In the United States, toxicity testing is not required to register and get approval to use a chemical, with the exception of two big groups, and those are the two groups on this slide: pharmaceuticals and pesticides. To get those approved for use, you do have to do toxicity testing and approval. So what we've done is we've developed approaches for developing screening benchmarks for both of these by using the readily available information. For pharmaceuticals, that is using the lowest therapeutic dose, and then information on the drug label in terms of who might be sensitive or who should not be taking the medication, that sort of thing. And then for the pesticide rapid assessments, we leverage EPA's registration information to identify, to sort of shortcut an in-depth review and generate screening benchmarks. So these are screening benchmarks, which means we would not advise using them to do a quantitative risk assessment, but they can be useful in helping you prioritize whether something should take a closer look at something, or I know the Pollution Control Agency has used it to help inform some of their monitoring efforts. So we do have about 120 pharmaceutical screening benchmarks, and then I think we're over 200 pesticide rapid assessment benchmarks so far as well. Then another, I don't know if I call it a special project, but certainly something that has...
Sorry to interrupt, Helen. We got one more question coming in,
sure.
so maybe you want to wrap it, or address it as you're going through. Are algal toxins associated with harmful algal blooms considered contaminants of emerging concern?
Yes, we have had several nominated, and we have developed guidance for at least two of those: anatoxin and microcystin. So one of the things for the PFAS, they need special consideration because they are very special chemicals. They are highly soluble, but many of them also bioaccumulate in the human body, which is an extremely rare, and I'm hoping personally that it's so rare that they're the only ones that do this, but that is an extremely unusual combination. And this slide sort of summarizes why we had to do somewhat of a non-standard approach to analyzing and developing guidance for some of these. So particularly those with long half-lives. Because of those long half-lives, there are really multiple concerns. It means short-term exposures will stay in the body for years. So even though you may be exposed for a short period of time, internally you'll be exposed for an extended period of time. They accumulate in the body. You do sort of plateau out at a certain level after many years of exposure. But we have also learned, and there's a lot of literature and continues to be literature on this, that body burdens that have accumulated over time, particularly in mothers or mothers-to-be, that can be transferred placentally. These chemicals easily cross the placenta, and they also are excreted in breast milk. And if someone has been exposed for long enough and at high enough concentrations, it is possible that the breast milk itself could exceed the water concentrations that the individual is being exposed to. So both of those things can result in significant transfer to the offspring. In addition, that developmental period is also a very sensitive effect for many of these PFAS. So our concern was that our standard approach, which is really reflected in that equation at the bottom, does not address these, what we refer to as sort of indirect exposure pathways, because the infant isn't exposed by directly drinking the water, but it's exposed mainly through transfer of accumulated body burden from the mother, at least part of it, to the infant. And that equation does not address that at all. And our concern was that if that exposure was significant enough, infants could be experiencing much higher serum concentrations in early in life than those long-term steady state concentrations. And so we came up with a way of trying to look at that, quantitate it so that we could include it in our guidance development. So we developed what we refer to as a toxicokinetic model. What toxicokinetic means really in simple terms is what the body does to the chemical, the absorption, metabolism, excretion, distribution, that sort of thing. These chemicals are readily absorbed. They are not metabolized, except for some of the precursors. They are largely eliminated through the kidneys, and they distribute in the extracellular fluid like our serum and plasma and the blood system. So we developed an Excel base, so it's very transparent. 2 compartments. We have the mother and the infant. And then this spreadsheet, really, basically what it does is it calculates a daily serum concentration for the offspring. And the equation that's shown is really what's used to basically for the entire model. So it's really just a function. Serum is a function of basically what goes into the body and what goes out of the body. And the rate at which it goes in and goes out. And this model simulates these daily serum concentrations depending on, water level and how much water a person is drinking, that sort of thing. So we run this model iteratively, adjusting the water concentration by what the serum concentrations are that are produced, that, whether there's a peak concentration or the steady state concentration. So we've used this model for 3 long chain PFAS so far: PFOA, PFHXS, and PFOS. And you can see there are some similarities and some differences across the sort of serum curves that you see here. So the differences are because there are slightly differences in how efficiently they're transferred, both placentally and by breast milk, and their half-lives differ. But the key similarity is that it is the breastfed infant who is the most highly exposed because of the accumulated body burden in the mother that is then transferred, at least part of it is transferred to the infant. So when we developed our water guidance, particularly for these 3 chemicals, we based it on protecting the breastfed infant by making sure that the water concentration was low enough such that the body burden that accumulates in the mother and that she could then transfer to the infant would not exceed levels of concern in the infant. And that is what we used for these 3 contaminants. And there may be other PFAS that we use it for as well going forward. But it did require us to do something beyond our standard approach. So you probably heard mentioned several times that data is needed in order to do those calculations. In order to put numbers into that equation and get a number out, you have to have data. And when data is limited, so are our options. We can use data from a closely related chemical to fill some data gaps. And we have done that with several chemicals. But if the information is so limited or non-existent, right now it really leaves us almost with no options but to have no guidance. There's very little that we can say, and believe me, that is not satisfactory for anyone, particularly if something is found in a water source. And this is the number one issue for many of the PFAS. We have many PFAS that have been nominated to our program, and only a very small number of them we've been able to actually develop numerical guidance. And we are looking at some other options. So that leads me into more special activities, one of which we refer to as the alternative risk assessment methodology. Basically, we are looking for other tools besides the one hammer that we have, which is that equation, for being able to provide some level of risk context, even if it might be qualitative risk context. So we've identified a couple of good candidates. One is referred to as the LD50 extrapolation. So it is really extrapolating from what is an acutely toxic dose, applying a large extrapolation factor to estimate what is, in essence, a ballpark reference dose for chronic exposure. There's another one called toxicological threshold of concern. This was originally designed for food impurities. And right now, the Food and Drug Administration is doing a massive revision and enhancement of that decision tree, which we are tracking and are hoping that it comes out in publication. It was supposed to be published over 2 years ago, and we're still kind of waiting. But that is another very good candidate that may allow us to provide some level of risk context. And what I mean by that, it could be someone finds chemical X in the water. We could at least say that concentration is well below levels we might be concerned with, which is an easier question to answer than develop guidance, but we may be able to still provide some kind of risk context. We also have an ongoing cooperative agreement with
Helen, I'll interrupt and jump in for just a second because we have a question specific to PFAS chemicals.
Okay.
Do most or all PFAS chemicals dissociate in the body into their acid and conjugate base?
I believe most of them exist as, they do dissociate into their, I think, ionic form in the body. So most of the toxicity studies, for example, may be conducted with sodium salt or something, but they dissociate in the body.
Thanks. And Brian, if you've got a follow-up question, go ahead and put it in the chat. Thanks. Go ahead.
We have a cooperative agreement with, actually it's the Computational Toxin Exposure Group at EPA. So we've completed almost, for the most part, the semi-automation of the exposure screening using EPA's chemical dashboard, chemical properties and chemical use database. So it's not completely automated, but semi-automated, so it allows us to do that more efficiently. And we also, it also brought in some new sources of information for us. We are just starting the conversation and initiating another project, which is in essence reversing that semi-automation process. So it uses the same parameters for the screening and the scoring, but it kind of reverses it to see if we can proactively identify chemicals of potential concern from the, in essence, universe of chemicals that are in the dashboard. We want to make sure that we've identified chemicals that might be of concern. And this is also a question that we are very frequently asked by stakeholders, and to date really have not found a good way of actually addressing that. So we want to make sure that, if the chemicals that we're looking at are the best ones to be looking at. And then on the toxicity, again, this has not started yet, but we're hoping to semi-automate that toxicity screening as well, using the chemical dashboard toxicity information. And that would include some of their bioassay databases as well, which historically we have not been using those in vitro studies. And then we have another program within our section called the Toxic Free Kids. And they are sort of mandated by a legislative session law to identify chemicals of high priority for children's products. And so they are also assisting in sort of standardizing and semi-automating the exposure and toxicity screening for that particular program that has this the information that's used to identify those priority chemicals is actually pretty clearly listed in the authorizing legislation. So it's a little bit different than our program, but the concept I think is similar. And then other activities, we have microbial risk assessment. So we have someone who is involved in looking at microbial assessment for water reuse projects. And these are non-potable reuse purposes like flushing toilets and irrigation to date. We also have a special project on disinfection byproducts. If you remember, they were a noticeable slice of the pie in terms of nominations, but our standard procedure really only focuses on risks that are posed by those chemicals. And we all acknowledge that disinfection byproducts exist because systems are disinfected. And there's a very, very good reason why we disinfect water systems. It's to prevent infectious disease. So we have pulled out, I think, almost a dozen that have been nominated and have put them in a special project, which we intend to look at not only the risks, but also the benefits. It's sort of a balancing that with the benefits of disinfection and the necessity to do that. And also, I think, a wider direct engagement with stakeholders that would be involved and impacted by looking at those types of compounds. And then here's the microplastics. We are part of a multi-agency effort, which I think right now is probably led by the Pollution Control Agency, but it does include multiple agencies. And right now, I think the effort's mainly still focusing on identifying good, repeatable analytical methods, doing monitoring within Minnesota, and then I think a future would probably be more looking at the potential risks. We also use part of our funds to fund staff and equipment at the Public Health Lab, and that position is involved with developing or improving analytical capabilities. I know they have worked directly with the Pollution Control Agency on some of their monitoring efforts to create analytical methods as well as to improve them. And then last but not least, the education and outreach grants. We have made multiple grants to local units of government, nonprofits, et cetera, which are focused on increasing the public awareness in terms of chemical use, using it wisely, and how to minimize exposure to yourself, but also how to minimize impacts to the environment. And I think this is almost to the end. So here's a list of resources. I understand, I think this slides will be provided to everybody. It was my understanding. So here again is our homepage, which leads to a lot of other information. The methodology, that multi-duration methodology that I mentioned to you, we do have a publication that talks about the significance of looking at these multiple durations, including short-term durations. And we also have a publication for that toxicokinetic model. Both of these publications are open access, so you should be able to obtain them and download them if you are interested. There should be, you don't need to go through a library or anything like that. I also added the Pollution Control Agency's Contaminant of Emerging Concern, a couple links there. Our program does not go out and monitor, but the Pollution Control Agency, as well as others, do that. And then again, last but not least, I did put in a link for the US EPA Office of Water methodology that we used as a starting point for our screening assessment. This is a large document, and I believe the screening, metrics and scoring and that kind of stuff are in, I believe it's Appendix A of that document, if someone was really interested in looking at that. And then this is my last slide. This is my contact information if anyone has follow-up questions that occur to them after the presentation. And other than that, I'll just open it up for questions.
Great, thanks so much. We are all applauding in our homes, so I hope you can hear us from here. We do have one question that came in the chat. Where is the best place to find out if MDH updates its guidance on private well testing?
That would probably with well management. And in terms of testing on private wells, my understanding is that right now, I think we have recommendations. Since these are private wells, regular testing is usually up to the well owner. When the well is constructed and put in, the Department of Health does sample, and they have the authority to have the well driller do a sample, and it's analyzed, I believe, for arsenic, nitrates, and bacteria. and to see if any of those are elevated. But my understanding is we actually had to obtain the authority to do those sampling, et cetera. So we can't just decide, let's say tomorrow, oh, we're going to go out and start sampling wells for selenium or something. We can't actually do that. You have to have permission of the well owner. And we certainly do sampling of private wells, let's say in the East Metro, related to the PFAS plume. But again, we have to get permission from well owners to actually take a sample. But that's part of an investigation for a plume investigation. But unless there's a concern about, a contaminant plume, from a landfill or something else, well owners are typically responsible for testing their own water.
Thanks. That's helpful. Brian, why don't you unmute, and Brian Davis, go ahead and ask your question, because no one wants to listen to me. I'm pretty far out of chemistry. Slowly pronounced perfluorooctanoic, Go ahead, Brian.
Yeah, perfluorooctanoic acid. I'm showing an example there I just found online at the ITRC website of one of the more commonly discussed PFAS compounds, just PFOA. And so the question I had is, well, in what form are these compounds found at environmental pHs, like in water or in the human body, in blood? Water pH can be anywhere from 5.5 to 7.5, and blood pH is a little higher, I think, like 8.5 sometimes. So the question I had is, in what form are the compounds found? Are they the acid form, or are they in the form after they've dissociated into hydronium ion and the base? So that's the chart that I found there is just for PFOA, but there are hundreds or thousands of these chemicals, and I'm just wondering about their bioaccumulative nature in the body, if that's affected by the pH, if they're in their ionic form or in their as the the organic acid before it dissociates. Is that making sense?
Somewhat. My last chemistry class was a really long time ago, but my understanding is I know the pKa for many of these compounds is such that they are extremely acidic, and in fact, that is one of the things that is a challenge to conducting some of the toxicity testing, because at higher doses, for example, if you're trying to do a dietary study, at some of the higher doses, the animals will absolutely refuse to eat the food. It is so acidic. So it is an issue. My understanding is it disassociates is typically what happens. And I don't know if there's been anything to suggest that has a direct impact on in terms of toxicity. I think one of the things that it's felt that their structures are fairly similar to fatty acid structures. So that has led to some speculation about why humans tend to reabsorb them back into the body in the kidney, because the body may think, oh, this looks like something that's very useful to the body. We need to keep this. But I think, how they exert their toxicity, et cetera, is still somewhat of a mystery, because it's not like they cause one particular type of effect. There's a wide range of effects that they seem to elicit. So they continue to be extremely challenging to understand.
It's one area of interest with this is just on the water treatment side in the East Metro, using granular activated carbon for adsorption, which is a typical way to remove an organic contaminant, versus a new process which is being researched, which is actually using an ion exchange resin, like for a water softener, but in this case, it's for the anion form. It's for the dissociated form there with the negative charge on it. So I don't know, these, it's interesting just the chemistry of it, for nerdy people like me, but it also has like a water treatment aspect to it, which is the subject of like $700 million of spending coming up in the East Metro. So that's one of the reasons I'm interested in it. Anyway, I just wanted to ask.
Cool.
Yes,
Thanks so much. Oh, we are really close to the end of time, and there's one more question that I think might have like a yes, no, or a short answer. So I'll just ask it, and if I'm wrong, we can maybe take care of it over email. But the question is, what would a ballpark estimate of an LD50 for a PFAS compound be?
Oh, well, I think that greatly depends on the compound. And what we have found, which is really frustrating, believe me, is that for many of these alternative methods that we're looking at, the PFAS have such unique characteristics that these methods do not work for them. So for example, a lot of the PFAS are so acidic that an LD50 is extremely low because it corrodes the stomach of the test animal. And so it will kill that animal at fairly low concentrations. And it's not really indicative of a low level chronic exposure, especially if something that bioaccumulates. So for anything that's bioaccumulative or that's corrosive, the LD50 method cannot be used. So.
Interesting. Thank you. And thanks so much. We're 2 minutes over, so I'll hang us up here. But gosh, I appreciate everybody coming. And one more round of applause for Helen. Thanks so much for joining us. This was a really great presentation. Thanks so much.
Thank you for inviting me. And please, if people have questions, they can feel free to email me.
Awesome. Great. Thanks. Well, everyone enjoy your afternoon. Thanks for coming.